Dry saturated steam at 11 bar, convergent divergent nozzle, leaves at pressure 2 bar, P3 2 bar. Steam is initially dry and saturated, N equals to 1.135. The flow is adiabatic and frictionless. It means that S1 equals to S2 equals to what? S3. You want to find out exit velocity of steam, that is V3. You want to find out ratio of cross section at exit and at throat. You want to find out A3 by A2. For maximum discharge, so we always design for what? Maximum discharge. Because Mach number equal to what? 1. Assume index of adiabatic expansion is 1.135. That we already taken. Very first job is to calculate P2 using standard ratio. P2 by P1. 2 upon n minus n plus 1. N upon n minus 1. We know this ratio is standard 0.577. So what is P2? 0.577 multiplied by 11. 6.34. Moliere will approximate to what? 6.5 bar for quick calculation. 10 and 20. How many lines are there? 1, 2, 3, 4. I have to go count this. 1, 2, 3, 4, 5. 5 lines. 5 lines. We want what? Is this line? Second line is 12 bar. Between 10 and 12. Second line is 12. 14, 16, 18. So 11 line is between first and second. So you have to construct it. Got the point? This point. And you have to intersect with what? Dry and saturated line. Now record enthalpy here. All of you got 2780. Okay, if you are located done, draw vertical line first. 0.2. 6.5. Okay, we have line of 5, then we have line of 6, then we have line of 7. Line of 5, then line of 6, line of 7. What is P2? 6.5. Between 6 and 5, draw one imaginary line. Very close to 2680. Last point. What is back pressure? 2 bar. So 2 bar line is available. Record enthalpy. You write down this value in the HS diagram. The point number 2 is the wet region. And point number 3 is also wet region. Now go back to the point number 2 here. Mark it. Now see the dryness fraction line there. Dryness fraction line is this one. So x2 equal to what? 0.96. All of you got it? Now back to last point. Now see dryness fraction. Is it less than 0.9? But it's very close to 0.9. 89 will make it. It's very close to 0.9. Dryness fraction line. 0.96. What is dryness at this point? 0.89. Okay. So two value will make it ready first. One is V2. V2 is X2 into Vg at 6 point. We have taken data for 6.5 bar. So is 0.96. And what is Vg at 6.4? We got V2 equals to Vg at 6.4 is 0.296 and Vg at 2 bar is 0.885. So we know the specific volume at point number 2 and point number 3. Are we able to calculate V2, capital V2? So capital V2 equals to velocity is under root of 2 times h2 multiplied by 1000. V3 equals to under root of 2 times H1 minus H3. So I think the first answer you have to find out exit velocity of steam. So this is my answer 1. Then I have to find out the ratio. For ratio, I will write down the formula for m dot. V2 divided by specific volume multiplied by A3 V3 divided by specific volume. So we want A3 by A2. So what is A3 by A2? The answer is 1.6. Dry saturated steam at a pressure of what? 7 bar. So right. P1 equals to 7 bar. It is dry and saturated. So x1 equal to what? 1. Naturally index is what? 1.135. What is the mass point of nozzle is given? M dot is 5 kg per second. Second is very large. Discharges to pressure of what? 1.8 bar. So P3 equals to 1.8 bar. Due to friction occur only in divergent part. It means S1 equals to what? S2. But S3 will be greater than S2. So what is the loss? Loss is 12. So what is efficiency? 88%. Of the total isentropic enthalpy drop, index is this. Determine the cross-sectional area at the throat and exit. You want to find out what? A2? And you want to... Is the first point is on dry and saturate line? Yes. So this one is 7 bar. The point on dry saturate line. From this point, you have to draw a vertical. P2 first. P2 by P1. I think this ratio is fixed 0.577. So what is the value of P2? 4 bar? So P2 is 4 bar. Pressure is 1.8 bar. We want H2, we want H3. Is point number 2 is here or point number 3 is here? At this point. And 3 will be here. We are moving from 1 to 2, then we are moving from 2 to 3. Supply pressure is 7 bar. So this one is 5, this one is 6, this one is 7. 7 is third line. 7 is third line. Mark this point. This is point number 1 on 7 bar line. 1, 2, 3, 4. Is it 2760? 2760. V3 equals to under root of 2 times H1 minus H3. So I think the first answer you have to find out exit velocity of steam. So this is my answer 1. Then I have to find out the ratio. For ratio, I will write down the formula for m dot as A1 V1 by small, not A1. I have to write down A2 V2. This one is A2 V2 divided by specific volume multiplied by A3 V3 divided by specific volume. So we want A3 by A2. So what is A3 by A2? Is A3 by A2, is it equals to V2 by V3 multiplied by V3 divided by V2. The final answer is 1.6. Dry saturated steam at a pressure of what? 7 bar. So right. P1 equals to 7 bar. Initially it is dry and saturated. So x1 equal to what? 1. Naturally index is what? 1.135. What is the mass point of nozzle is given? M dot is 5 kg per second. 5 kg second is very large. discharges to pressure of what? 1.8 bar. So P3 equals to 1.8 bar. I have to confirm. Whether he says convergent divergent? Yes, he says convergent divergent. So confirm 1.8 bar. The loss due to friction occur only in divergent part. It means S1 equals to what? S2. But S3 will be greater than S2. So what is the loss? Loss is 12. So what is efficiency? 88%. Of the total isentropic enthalpy drop, index is this. Determine the cross-sectional area at the throat and exit. You want to find out what? A2? And you want to find out what? V2. Is the first point is on dry and saturate line? Yes. So this one is 7 bar. This is a point on dry saturate line. From this point you have to draw a vertical. Now we need to calculate P2 first. P2 by P1. I think this ratio is fixed 0.577. So what is the value of P2? 4 bar? So P2 is 4 bar. Back pressure is 1.8 bar. So what is need actually? What we need, H1 we want H2, we want H3. Is point number 2 is here or point number 3 is here? At this point. And 3 will be here. We are moving from 1 to 2, then we are moving from 2 to 3. Supply pressure is 7 bar. So this one is 5, this one is 6, this one is 7. 7 is third line. 7 is third line. Mark this point. This is point number 1 on 7 bar line. Record enthalpy 1, 2, 3, 4. Is it 2760? 2760. Draw vertical from this line on graph. 4 bar. 4 bar line is available. We have 3 bar, we have 4 bar. 4 bar is this line. 60 or 50? Don't say. You want to find out dryness also. You want to find out dryness also. This one is 0.95, so this is 0.94 in 6. 0.96. What is back pressure? 1.8. Is 1 available? 1 available. Is 1.5 available? And 2 available. So approximately middle line between these two will be 1.75. 1, 2, 3. Is it 2530? So we have recorded this value and we also find out dryness fraction at this. X2. Is it 0.96? Now you do first one. You use the nozzle efficiency. Nozzle efficiency defined as H1 minus H3 dash. H1 minus H3. This data and efficiency equal to 88 and calculate H3 dash. So we got H3 dash equal to 2557.6. To record the value of X3 dash, we have two options. One is Mollier and one is steam table. So I prefer steam table because I am not able to locate this value exact. So this equals to HF plus X3 dash HFG. What is the pressure at point number 3? 1.8 bar. Collect data from steam table and find out X3 dash. This is always a better option. 0.93. At point number 2, V2 equal to X2 into VG2. Point number 2 at what pressure? 4 bar. Wait. All calculation at one time. V3 dash equals to what? X3 dash Vg at what pressure? 1.8 bar. Now open the steam table and do both calculation. It is over. Okay, let's calculate V2. V2 equals to under root of 2 times of H1 minus H2 into 1000. This answer is 447. M dot equals to A2 V2 divided by specific volume. Mass is given as 5. Mass is 5. Specific volume is known, velocity is known, so we can calculate A2. Your answer will come in meter square. If answer is very small, then write in cm square. We can make it 49.6 10 to the power minus 4. So our answer is 49.6 10 to the power minus 4 means cm square. What is the velocity at exit? Under root of 2 times or h3 dash. This is dash because it's an actual point. So velocity is 636. Repeat the formula for m dot volume. 60. These are all approximate answer.